Today we're here at the AC Service Tech Answers podcast with my good friend Ty Branneman, and we're getting ready to answer some of your questions from the YouTube videos.
What's a better way to start the day than hanging out with your good friend and being able to help other people out?
A technician by the name of Brandon asks, how do I troubleshoot ECM fan motors? They are so complex.
It's a great question. And it's really just, we're looking at the same thing. It's an electromagnetic motor. It's moving air across it. Now, an ECM motor, it just has a little extra level in it where it's control the volume. So we call them constant volume motors. They're trying to move the same amount of air. Where the old motors, they just turned at a certain speed. So now that we're able to control the air as we have an air restriction, they're able to just speed up more to make sure we get the same amount of air across that coil. And that's what we want. We want to make sure we have the correct amount of air across the coil. So in the complexity to make that happen, we add a little control board in it, and it's able to read the back EMF. We're able to convert that to like a three-phase DC motor to be able to control it. And we need a little control board to make that happen. As far as diagnosing it goes, there's very specific steps that tell you exactly what to check. I can't do it without a visual, but and there's also some nice little tools we can plug in and do these basic simple checks. It just comes down to some simple steps. We want to know, is there an issue with the motor itself, or is it going to be with the module? And to check the motor, the first step is just the bearings. We can spin that blower wheel, see if it's turning. And if it's not turning very well, we know we have bad bearings. We're going to have to replace the motor and module. Then we can take the module off. We can use our meter, and on that motor's got simply 3 pins in there, and it's wound like a 3-phase motor. We want to check between all 3 pins, and they should have the same amount of resistance. If they don't, we know that we have a bad motor. We need to replace the motor and the module. Now, if the motor itself is good, sometimes we can change just that module out. We want to look in that module and see if there's any burnt spots in there. And they also make some pretty cool tools now. We can have some meters we can plug into that make that motor work separately from the controls. And each individual module has test pins, and we can look up those test pins, and it can tell us exactly where to check and where to apply voltage to make sure we're working. But simply, I like to take the simple approach first, and just those quick little checks, we can see what's happening.
Yeah. So there's a couple different types of ECM motors, and you just got to be aware of which one's what. You know, if it has spade terminals, a lot of times, either on a plug on the motor or on a wiring harness coming off of the motor, a lot of times those are constant torque ECM motors, and they require a 24-volt signal in order to tell the motor what speed it's going to run at. And so it takes high voltage. And so it could be rated at a 120-volt motor or a 240-volt motor, and that's going to be live all the time. That's a very important thing to know. And then you're going to have a common over there with that wiring harness or terminal with the high voltage, which is actually for the low voltage. And so what you want to do, you can, if the motor's not running, you can see, well, do I even have 24 volts heading to this motor? And so you can measure that with a multimeter on each of the speed pins. And so it's simple for the circuit board inside the furnace or air handler. It's just sending a 24-volt signal to the module where it has a circuit board, and it's just waiting for a 24-volt signal on one of the, say, 4 or 5 speed terminals, and not all of them are going to be programmed. It gets a little bit more complex when you have the 16-pin or the other ones where it's using direct current signals and things that it's communicating, between the module and the circuit board. And so there are different voltage signals that you're going to need to measure, or you can use the different testing tools that are out there. But the object is you want to see if the circuit board is sending a signal to the module in order to tell it to turn on. And like you said, you can do the simple tests, visual test, smell test with the power off. Try to feel just if there's a restriction at the blower wheel, like if it's locked up, if it's bad bearings. Sometimes it's just slid off the axle and it's rubbing against the squirrel cage. You want to take those obvious steps first.
Absolutely. And don't be afraid of those. So if something new, do some research, look at those specific motor you're working on, and you learn. And then the next time you see that motor, it becomes easier and easier and easier. I've seen people before that they just try to replace those with a different type of motor. And we want to go back with what's there. The manufacturer did the test, make sure that was the motor that's required. And we want to make sure that we're going back with that. And as you build those skills, it gets easier to do those diagnostics, and you're doing the right thing for the customer.
Yeah. And so that's a great point. So when you are replacing those motors, you're either going to go to the distributor and basically using the model number of the air handler or the furnace, you can get the same size motor that was programmed the same way to put in there. If you're using an aftermarket ECM motor, you're going to also want to pay special extra attention to what speeds it's running at, and definitely you want to be measuring the airflow to make sure you have the correct airflow for during air conditioning and heating mode. That initial ECM motor is programmed for that specific model. You can't just take one that came out of, say, a 5-ton unit and put it into a 2-ton unit. It's not going to work properly, and you just need to be aware of that.
Yep. And most of those instructions are pretty well done. They have step by steps. So just take some time, read through it, follow the steps, and it's not nearly as scary as it sounds.
Technician by the name of Willie asks, how do I really know if a circuit board is bad? The manufacturers don't give guidance on testing these. With a circuit board, you have a series of inputs and you have a series of outputs. You might have little black boxes on the circuit boards. Those are relays. And so you want to see where, each of the wires connect onto the circuit board. If you're doing diagnosis with a circuit board, you don't really want to be doing that if you're drawing current already. So you don't want to be doing that while the blower motor is running. You want to disconnect the blower motor, and you can actually disconnect the high voltage loads in order to check electrical resistance across those little relays. When it's controlling something like an ECM motor, it may not have those relays, but you want to know, say if it's a furnace, you want to know the sequence of operation, what the circuit board's supposed to power first in its sequence. You want to know the inputs coming into the board in order to tell it what to do. And that's coming from the thermostat wire and actually from the thermostat. And really, it's from the user setting the thermostat. So it's just a series of steps, and you need to know, what to look for first. And it's the inputs first.
That's exactly right. Just understanding what it's supposed to do, then is it doing that thing? That's one of the big steps. So if you don't understand the sequence of operation of that furnace, it's going to be really difficult doing it. But if you understand, hey, we get a call for heat from the thermostat connects R to W. Are we getting that R and W to the control board first? Hey, we are getting that signal. Next, it should do a pre-purge. So you know that we should be sending 120 volts to the inducer fan motor. So you check to see if it's actually doing that. It's doing that, the motor's working, but then you know that the pressure switch should close and we should be getting 24 volts back to the control board now. So we can follow those wires all the way back. We can check it at the pressure switch or at the board. And each one of those steps, as you go through that whole list, you can check every one of those and you can find out, is it the board or the component?
Yeah. It becomes a little bit, I feel like, dicey for newer technicians with the sequence of operation. And then all of a sudden the flame goes out and it just stops in the middle of it once it starts burning. Like, say, for instance, after 3 seconds, maybe if there's a flame rectification problem. Some of the newer technicians aren't aware you need to check for grounds and things like that, and maybe don't understand how the flame rectification process works. And so then they just go and blame the circuit board as being bad. They come back maybe after a day or two with the circuit board and they go put that in, and the furnace is still not working properly. And it's still the same problem. So it's really bad, because basically at that point, you have to fess up. You didn't know what you were doing. That's what you should do. You shouldn't be then saying, oh, it's that part and it's another part that's bad. You really want to be a good diagnoser on a furnace or air handler. You want to know how these systems work in order to properly diagnose them.
I'd actually like to also recommend putting in a surge protector, especially if it's a gas furnace. These control boards, it's essentially a computer. And anytime we have our computers plugged in, we have some kind of a surge protector protection on it. So having that for your control boards, I think, is a good idea. And also looking at moisture. Is there any kind of water damage? Is that moisture coming off the coil or coming down a flue pipe? Or we want to make sure that what externally could have caused this to fail.
Yeah. So one more thing is, like, you do need to just be aware of maybe what version of furnace you're looking at. What type of air handler you're looking at. Some air handlers, they don't even have a circuit board inside. Some do. Some are powering a PSC motor. The circuit board design a lot of times is based on what type of blower you have. And so you really need to be able to pay attention to that and understand what's going on. It takes some component identification. And so you just want to start being aware. And a good way to start doing this is, if your company is pulling a bunch of systems out, you could take those or learn some from it, maybe off the clock potentially. Talk to your employer. I know every time that you really talk to an employer and say, look, I want to learn more, I want to try to figure this out, they've been doing it for a long time. They want you to be better. And so they're probably going to be pointing you towards these resources, and they might even put you with a senior tech that can tell you, hey, here's the different types of parts we tend to run into uh, in this area. Or, you can go and look on some videos and things like that, some YouTube videos, in order to determine, like what kind of parts control what.
Even if you have a furnace that's not running and you can't do
Yeah.
much with it, following the schematic on the board and then one by one, every single wire in the schematic, following it to its component from the control board. That taught me a lot.
Yeah, absolutely. A technician by the name of Mike asks, how do I know the condition of the underside of the indoor coil if I can't get to it? When I pull these out during replacements, many of these are clogged with dust. Are these serviceable and how do I clean them? What am I missing here? That's there's a lot to that question.
There is a lot, and there's many different options to that, and every situation and budget's different. My new preferred method is a camera. We have these little cameras
Mhm.
that we can take the cover off, we can lift the drain pan up just enough and get this camera inside of there, turn it up, and we can look at the coil. We can actually have a picture. We can take a picture, and we can even show the customer. That's my preferred method. There are some old school methods. I remember on a gas furnace before, I've pulled the blower out and actually crawled there and looked through the heat exchanger, which works on an 80% furnace, but that's not going to work on a
Yeah.
90% furnace. However, the 90% furnace, you also have that secondary heat exchanger that looks just like a coil. It's important to check as well.
Yeah. Yeah. The secondary heat exchanger, a lot of times the fins are more spread out. A lot of times the dust even gets past them and then gets up into the bottom of the coil. But you can check this with static pressure. If you have a high pressure drop across that coil, you can know that you have a restriction there. And so if a customer hasn't changed their filter, or the filter is in there and kind of collapsed on itself and the air is getting around it, you can basically figure that that coil has got some dust on it. And that coil accumulates dust because in air conditioning mode, it's wet. And so any dust just gets stuck right to it. And then it just makes a mat. If you have like pets in there, it's just going to accumulate on the bottom. And so you can look up the model number of the evaporator coil, the indoor coil, and it'll tell you what the dry static pressure drop should be and the wet static pressure drop should be. And so you can take a measurement with a static pressure tip and a water column manometer right before and right after in order to see what that pressure drop really is. And if it's much higher or even a little bit higher, it's a little bit clogged. If it's much higher, that's where your problem is.
Yep, I agree. It's a great method.
You could also pull the A piece on an A coil on the front of the evaporator coil. You could pull that off or pull a couple screws out and kind of look up inside. But a lot of times that's very difficult. You have to first take the cover off and pull that sheet of galvanized metal out of there, or maybe it's aluminum. You could, if the ductwork has a flex on it, you could pop the evaporator coil off and kind of push it back a little bit if the line set has extra length on it, or you could even potentially pull the furnace forward a little bit. You have to check the exhaust. There's a bunch of different ways. I really prefer using that camera, like you said. You can drill, a unibit into a certain section of maybe even the plate in the front of the coil where there's no tubing at, and then you could stick the camera right in there. It's easy enough if you can just take a utility knife, cut the sealant where the evaporator coil sits on top of the furnace at. Like you said, just shoving that camera up inside of there. And some of the cameras even have an ability to kind of move the end around. It kind of pitches upwards or pitches downwards and allows you to look inside. And some have lights on them. And so these are really good tools that we don't have to go, like you said, pulling the blower motor out in order to see it.
That's definitely been a big help. But in the old days, we used to have to try to get a mirror up in there
Yeah.
and see it with a flashlight, and it was always a challenge to really know if you got it good. But being able to see it with those scopes and show the customer, that's a great method for me. It's one of the ones I prefer. But I also like the airflow method. It's just you don't have something to show the customer with that, but it's definitely a great way of knowing condition of that coil.
Yeah. Yeah. So once you find that you have a clogged coil, then you're going to have to clean it. So if you have some room with the line set, maybe you can pull the coil out, but most of the time you're going to have to end up recovering the refrigerant or pumping down in order to then move the coil out. Sometimes you can move the furnace out of the way. Sometimes you can take the plates off. I mean, you don't have to do any of this when you have a slab coil on an air handler because you can just get right to the back of the coil. It's great. It's awesome. But for the instances when everything's super tight, you're just going to have to try your best to get to it and maybe use a fin cone brush or pull some of the dust off of it. You're going to have to also be cautious with spraying cleaners in there and things like that, or water, because it's just with a vertical coil or a downflow, that water is just going to end up going into the furnace, or down into the ductwork. And so you have to be cautious with all these different things. And we just do our best in order to get that system back up and running.
And if you're using those chemicals, you got
Yeah.
to definitely make sure what you're working with. Now we have a lot of these microchannel coils.
Yeah.
And if you use the chemical we used to use back in our day, it'll eat away those microchannel coils. And that's, then you have a leaking coil, which is worse than a dirty coil.
Yeah. They have no rinse sprays from the can, or just spray bottles that you can use. And the condensate that forms during air conditioning mode should wash them off, but it is best to also just spray that with water. You don't have to spray a ton of water, but you can just spray some to try to get some of that chemical off, because the thing is, it'll dry onto the coil, and then it'll be harder for that to come off. So while it's still wet, spray it down with some water, rinse it off when you can, and just try to do the best you can for your customer. And like Ty said, you have to be real careful with these microchannel coils, because it's aluminum that the refrigerant is traveling through, not copper. And so that's a big deal. Technician by the name of Tyler asks, I'm on a limited budget and just started out in HVAC. I have my basic hand tools and gauges. What should I buy next, and how much do I really need? Some tools are really expensive.
That's this is one of the big questions I get asked all the time. And it's a hard one to answer because it depends on what you're specifically doing. Now, some advice that I would have is don't just go and buy all the fancy tools. See what you're needing the most. See what your lead is using the most, and make those your target. I know that I've had students before, they'll go out to the job and who they're working with has one of these really fancy bags. And I think they're great bags, but they'll spend all their money on buying the bag and they have no tools to put in, or they'll go buy a really fancy meter and they're not to that point where they're using it. They need snips first, or they need something else first. So I don't understand, exactly what your specific job is, because it changes from job to job and across the country. So seeing what your lead's doing, being mindful of what tools you're going to need next, and then budging for that. Don't just go to the supply house and see the shiny tools and just start buying stuff, because you end up with a lot of debt and tools that you may not need for a while. So being mindful of what you're going to need next, make a budget and make a list and have goals. Hey, by 3 weeks, I want to save up enough to get this tool. And I think that's a safe way of doing it, because you can really get in a lot of debt fast,
Yeah.
especially with all these new fancy tools we might not need just yet.
Yeah. There's a lot of marketing that's happening and things like that, and it'll make the tools look really needed and useful. But the thing is, y- all of us, we cannot buy all of the different tools. There's too many.
I've tried.
You can't, you just can't. And so you really just need to invest in yourself a little at a time, and realize, like, if you're saying you're new to the field and you're probably new to this job. And so for whatever reason, if you had to move to a different location or a different company or something like that, the tools needed may change. What you need to do is invest in yourself a little at a time. Like you said, tin snips, different size pipe wrenches, different things that are going to make you more valuable on the job site, and you invest a little at a time. And I would definitely say to get more and more hand tools. I talked to some technicians and they're like, oh, I don't even do duct work, no metal work at all. They just, use the fiberboard. And so they have no idea. That's like a whole nother world to them that they've never even been a part of. And so they don't need it. Other technicians, they don't use certain tools. And so just a little at a time. You don't need the high-end troubleshooting tools first when you're just starting out. The first tool that you would get that's a troubleshooting one would probably be a multimeter. But you don't have to get the real expensive ones either.
That's right. And it's okay to have a lower quality tools when you're starting out. I know you're going to be working with leads and like only buy this brand. And it's kind of like, which is better, Ford, Chevy, Dodge, Toyota? You'll have a different answer everybody you ask, and they are solid that this is the best. So when you're starting out, it's okay to have a screwdriver that's not the best brand. And maybe it bends when you need it. And it's okay because it's a low enough cost and you can buy it. And then when you do get that higher quality brand, you have a much more appreciation for it. And it's great that when you get the new set of tools, you always have a backup set. So if something happens, you have a backup set. Or when you have a helper that's working under you and you're training, you have a backup set that they can use. So I love high quality tools. I really do. But I'm also aware that, hey, when I'm starting out doing things, I'll buy a low quality tool and see how it works, see what I like or dislike about it. So that when I'm ready to buy that quality tool, I know exactly what I'm looking for, and I know I'm going to appreciate it when I do buy it.
Yeah, tools are based on procedures that you use. And so to give it, for instance, like a vacuum procedure. that can be done 20, 30 different ways, right? So you might really want to pay attention to some of the other technicians in your job and see like what their setup is. You don't have to maybe get the same brand, but you can kind of see what the setup is. You don't need something fancy. And what I find a lot of times is a technician will spend a lot of their money on the wrong tool and they'll be regretting it. And then that makes them start thinking, am I even in the right field? It's gonna be too costly to buy all these tools. Don't buy these expensive tools until you can afford them. And when you do buy them, you're kind of hoping that you're looking like very productive and you are being productive because of the tools and you're getting raises as you move on. And so you can't just spend all of your money on it, but you do need a certain amount of tools, in order to be effective at your job. And you just want to show the employer that you're really looking to learn. You want to be put in different circumstances so that you can become more valuable and more knowledgeable. And so, yeah, you don't need a fancy bag when you start out, and you just kind of build your tools up. You can even go to flea markets and stuff. Some people might disagree with that, but I mean that's how I started. I got most of my what I would consider expensive pipe wrenches at flea markets. I had a 10-inch, a 12-inch, a 18-inch, 24-inch, because here where we're located at, we're working on boilers. That's number one, and they were all old and had black iron on them, and also piping, gas piping, and so that was crazy expensive for me. So I actually got them at half the cost, when I started out because of that. So you don't, one step at a time.
I think your three most important tools are going to be your integrity, your willingness to work, and your curiosity to want to continue to learn. I think those are your biggest tools. And if you have those tools, everything else is going to be easier.
Yeah. Yeah. I'll say your fourth one is your ability to read the tape measure. A technician by the name of Nick asks, I have a problem talking with and working with coworkers, and I want to learn more. What should I do? It's a really negative atmosphere. I thought HVAC was going to be cool, but this has not been such a good experience so far. That breaks my heart when I see those types of comments, because I know I was actually in that type of circumstance with the first company that I worked for. I was only there for 3 months, and I couldn't take it anymore. And it was kind of one of these things where they act as your friend, right, to try to get some more info, and then they just ride you real hard, and that would be, it's not okay. But they also, on top of that, didn't want to teach you, because then if they taught you, maybe you'd get a raise instead of them. That whole atmosphere from the company side to the employee side, that doesn't seem like a good environment to want to be in. And so for me, I ended up moving on to another company after I did a little self-check, a self-analysis, and said, am I working hard enough for these people to invest in me, or are they just kind of more being jerks? And I think you have to really weigh that, in your own mind, because you do need to work hard. And if you are not working hard, they're not going to be teaching you, because they're like, you have to make some money for the company. You do your best, you do the right thing. And sometimes you have to move on. Sometimes it might just be a shift in the company, or maybe you need to work with a different lead technician. I don't know.
There's an old saying that hurting people hurt others. And a lot of these people have been hurt. They've been mistreated. They've had people that mistreated them. And it's just a pattern. Like they say, sometimes abusive parents or then their kids become that same way. So you have to think you're going through this. And I'm so sorry. I've been through this. I've known a lot of people that's been through it. You want to learn as much as you can. What your limits are, your legalities, that's going to depend on your specific situation, but you can still learn a lot. You can learn about your character and plan your next move. Don't just get mad and quit.
Yes.
Plan your next move. And then when you get to this position where you're training somebody, I hope that you remember how you're feeling now, how that other person, how you're treating the other person, so that you can break that habit. We have a lot of differences between generations now, and how I grew up is different from how people are growing up today. And I'm trying to be very mindful of the differences of how technology plays in, the differences of how people communicate. And it can be challenging. And so I really strive to anybody else that's listening that maybe an older generation teaching some, even if it's from millennial to Generation Z, just one generation apart, be mindful that there's differences of how people have grown up, and try to be inclusive to them. Understand, hey, where they're coming from. You don't have to agree on everything, but just to understand this is somebody who wants to learn. How can I help this person? It's okay if we disagree on music or vehicles or hairstyles or anything else. how can I help this person be successful in the trade? Because that's what it really amounts to. And again, it breaks my heart that you're having to go through this. And I unfortunately hear this too often, but I can also tell you that there's a step beyond that. Learn what you can now. And then when you're in your own truck, or you're going to be having your own helper, or you're going to find that company that treats you right, and you're going to appreciate it so much more. And so it's going, HVAC isn't like this,
Yeah.
but there are specific jobs that are, unfortunately.
Yeah, I agree. So the biggest thing, like you said, to mention, to keep in mind is that you're going to have the ability to influence somebody else's life, and basically, who is the most valuable technician in a company? And I think that that is the one that teaches everybody else. And so that person is going to be valuable because they care about the other technicians. And basically, the employer is going to run a lot of the new technicians through and have them work with this teacher tech. A lot of good companies have those. And so in this way, the whole company gets on the same page. They're all going through the same type of teaching. And so that technician's job, I mean, is constantly running through helpers before that helper or apprentice goes and works with somebody else, because then they have to learn through that one individual. If you can be that individual, that's a huge deal. And so keep going at it. Yeah, HVAC is not like that. That just happens to be somebody's personality, and they're getting away with it, that type of atmosphere because they're in control of it. But the problem is it's been like they don't even realize they're doing it. Unfortunately, it's just been something that's been passed on to them, and they're repeating it. And that just comes down to personalities. So hang in, assess the situation. Don't that, like you said, I think that's a great point where you said, don't get mad and just leave. Have a plan. That's important. Yeah. So whether you're going to stick it out, whether you're going to communicate, whether you're going to try to get transferred into another person's service truck, whether you're going to, leave, communicate with the boss, whatever that's going to happen. Maybe you're just going to put your head down and just work harder, see what happens, continue to learn, and continue to invest in yourself at night. Keep learning, because they're going to end up having more respect for you once you are being more productive and more knowledgeable, and you need both. You need a healthy mix of both.
That's exactly right. And it's your future.
Yeah.
It doesn't matter what they think of you, or it's your future. You're going to be moving beyond that. And so set those goals. No matter what happens, you have these goals set. Work towards those goals. You're going to have things come at you and like, nothing is going to stop me. So you have to have those goals set. Where do you want to be? Because everything else is just a distraction.
Yeah. A technician by the name of Ginny asks, why is it called superheat if it's happening on the cold line and in the cold coil? That doesn't make any sense.
That's a great question. So when we think about superheat, we generally grow up thinking things are hot or cold compared to our body temperature. If it's warmer than our body temperature, it's hot. If it's colder than our body temperature, we consider that being cold. But we have to step back from our feelings and some of the things that we've grown up as naturally we've grown up thinking about this. And we have to look kind of back at a scientific standpoint. So we see water boiling, and water is boiling. And if we were to touch that, that's going to be extremely, extremely hot. But anything below water boiling is considered a subcooled liquid. It's actually cooled below its boiling point. And so even if it's 200 degrees to us and our feelings, that's hot. But according to the water's change of state, it's subcooled. So 200-degree water is a subcooled liquid. Now, we can also have water that's above 212. It would be a fully B steam. We can heat it to 213, 214. It we call a superheated vapor. So it's heated above its saturation point. So we can connect it to water and see how it can be superheated and subcooled, and it's separate from how our body does it. We can also apply it to other things in our day-to-day lives, such as we're breathing in this room right now, oxygen, and we're also breathing in nitrogen. Well, the temperature of this room is about 70 degrees. Well, nitrogen has a boiling point of negative 290 something degrees Fahrenheit. I can't remember the exact number, but it has a very, very low boiling point. That means that we're breathing nitrogen that's superheated vapor. Even if it was 0 degrees outside, 0 degrees is cold to me. But the nitrogen that we'd be breathing is superheated hundreds and hundreds of degrees. The oxygen has a boiling point of negative 200 and something degrees. And even at 0 degrees Fahrenheit, where I'm freezing, I am very unhappy. But the oxygen that we're breathing is still superheated above its boiling point. So refrigerant, we can manipulate its boiling point. So if we make refrigerant boil at 40 degrees Fahrenheit inside the evaporator coil and the air is 70 degrees, that 70-degree air is making that refrigerant boil, making it change state. And boiling is an actual cooling effect. So as that refrigerant's boiling, it's absorbing the heat out of the air. So we boil all the refrigerant from a liquid to a vapor, it's still at 40 degrees vapor. There's still heat in the air. So the heat from the air goes to that 40-degree vapor. But now that it's all vapor, the sensible temperature starts to change. So it heats up to 41 degrees, 42 degrees, but it's entirely a vapor, 43 degrees, 44. It can heat up to 50 degrees Fahrenheit. And it's a superheated vapor because it's superheated above its boiling point. So it's 10 degrees superheated above its boiling point. So the compressor is breathing a superheated vapor, just like we're breathing superheated nitrogen, superheated oxygen. We're breathing superheated vapor. The compressor's breathing that superheated vapor. So we have to separate our feelings from it. When we touch that line, I think of it as a low temperature to us, low temperature, but it's a low temperature, slow pressure superheated vapor. When we touch the liquid line, it's warm to us and our feelings, but it's a high temperature, high pressure, subcooled liquid. We have to kind of separate from it how our feeling is going to be and look at it from a standpoint of what it is.
I think you hit that out of the park. I got nothing to add to that one. Great job. A technician by the name of Jim asks, why do some air handlers not have a control board in them? How does that work? So it's most likely one of two things. Either the air handler is very old and there's just relays in them, or it's a very new one that has maybe a constant torque ECM fan motor. So it all is relative to the fan motor. So if it has a ECM fan motor that is controlled by 24 volts, as far as telling the module on the end of the blower motor what speed it should be running at, then technically you don't have to have a separate switching mechanism on the circuit board to separate the low voltage thermostat wire from the blower motor. So you could directly basically control the blower speeds by the thermostat wire with nothing really in between them. So some air handlers work that way, and some, like I said, may just have some relays, and most likely that's what he's asking.
Back in my day, that's all that we had was standard relays. We'd use a relay, whether it be a sequence or a contactor to control the heat elements, and we had a little fan relay that controlled the blower motor, and it was quite simple. But still, the whole thing is we want to be able to close contacts or open contacts. And just now, over time, they found out that for manufacturing purposes, they can more effectively do these time delay controls with circuit boards, and so they can control not only these relays but also the fancier motors where they can control whether it's constant torque or constant airflow. They're able to do all this a little bit more efficiently, and as time goes on we have more progression. So who knows what we'll have in 10 years from now.
Yeah, I think it's still valid to know how all of those relays work, have them in your truck, in your service truck. You can rebuild things, get things up and running. When you don't have the exact, say, circuit board for an air handler, you can kind of get it back up and running. So it's really important to know the older systems and the newer systems. And so that's what I was always be doing in the classroom. I had a progression of different furnaces, different air handlers, old ones, new ones, different ones that had different blower motors in them. And you really want to be well versed in all the different varieties of what you're going to run into out in the field.
Relay know your relays.
Thanks, Ty. A technician by the name of Patrick asks, how do you diagnose a Wi-Fi thermostat? These Nest thermostats and other brands are really too computerized to be used for a simple furnace and AC. I usually talk the customer out of using these because I don't want to be the one having to figure out the problem later.
That's a great question. I want to start with not talking the customer out of something. So now I believe that I like to set a thermostat and leave it control the temperature of the house, and you shouldn't need to change it. I like that. But customers, they want to be able to control stuff. They want to see what their temperature is, and maybe they're going out of town and they want to raise the temperature up, or they're coming back home early. They want to control the temperature, and that's okay. So I don't want to talk the customer out of something they want, because they're always usually going to take that, back at us. But I do want to inform them, inform them of some of the things about temperature and humidity so they can have the best guide. I definitely have thermostats that I prefer over others. I have the brands that I prefer over others. But the big thing is we want to make sure that we're understanding that it's still just a switch. If we're calling for cooling, the thermostat's connecting R to G and R to Y. It's bringing on the indoor fan and the outdoor compressor. So that's essentially what it's doing, whether it's doing it off of just one temperature or a program or a Wi-Fi controlled where they can remotely monitor it, it still does those basic same things. And we want to make sure that we install it properly, like we're blocking the hole in the back so that we're not having air movement, that we're making sure the wires are secure, that we're stripping the wires correctly and not damaging the wire in the thermostat, and that we have that common wire hooked up, so it's not relying on just the battery. If we do those basic steps, then we know that we're installing that thermostat to the best of its ability. And then if the homeowner is having continuous issues with it after we've done those basic steps, then we can have that separate conversation with the homeowner of this thermostat's not meeting your needs or et cetera. But there's
Yeah.
definitely thermostats that I like more than others, but I try not to push that onto the customer because they're the ones living there. They're the ones dealing with it on an everyday basis.
Yeah, and it used to be that we would buy different thermostats for different applications, meaning different types of systems. If you had electric resistance heat, or you had a heat pump, or you had an air conditioner, a furnace and air conditioner, and now a lot of those things are all built into a single model of a thermostat. And so it's really important, especially with these Wi-Fi thermostats, to set them up properly to begin with. So all the selections and the customer preferences and stuff like that, maybe walk them through, not necessarily the setup there, but just what they're intending to use to control the system. So are they going away a lot? Are they what is their need? Do they just want it to be turning on and turning off when they come home and leave, kind of thing? Are they looking for just high efficiency? Are they looking for comfort? Like, what exactly do they want? Why are they getting this? And so on some service calls, I found it's just the problem is just the settings. It's set on the wrong type of system.
That's very common. I just go to customers, they'll install their own equipment. Hey, we need to reinstall this because of the hole in the back, the thermostat
Yeah.
wires being
Yeah.
shorted, and then just setting up for the correct system. And that's what we get paid. They can buy these parts
Yeah.
online, but we as the professionals understand how to read the installation manual from that thermostat. I remember I used to keep a copy of the installation manual, but now there's so many
Yeah.
thermostats you can't. So we can now look up and we can find
Yeah.
the PDFs of just about every thermostat out there. And then we can read through that and we can go just line by line of those thermostats and set them up. It was just 2 weeks ago. I set up a thermostat that I'd never seen before. And I did that very thing, just line by line, going through that PDF and setting it up for the system we're working with. And so far it's been working great. But with technology is going to be changing. I have a thermostat from the 1920s that has a mercury bulb thermometer on it, and it had a clock that you literally wound up every week on the back. And it was called a 7-day jewel. You had to wind it up every 7 days, and it was the first programmable heating only thermostat. And technology has come a long ways by then, but ultimately it comes down to being able to control the temperature for the customer. And so don't be afraid of that new technology. Just because it's different doesn't mean that it's bad, and we just adapt to it. And that's what we do.
Yeah, and don't feel bad about reading the thermostat instructions in front of the homeowner or the building owner. There's too many out there to now know all of them, and even there's too many settings. It just is what it is, and you might need to let them know that there's just too many. I have to look at this. Some customers, a lot of times, technicians might get overwhelmed when the customer's kind of like looking at you and trying to determine what's going on. Don't feel like they're assessing your skills. They're just actually wanting to learn. Like 9 times out of 10, they just wanted to know a little bit more about their system. That's it. You know?
That's a great point. That actually brings us to a separate topic about the homeowners watching it. And I know a lot of people get nervous about it. I sometimes still get nervous about it. We have to remember that that's their home. That's their castle. I mean, that's where they live. They've invested a lot of money into their home. And so they want to understand what's going on. And sometimes, if they're really distracting your work, you can say, hey, I just need to really concentrate and focus on this. But try to be mindful of not getting mad that they're watching you because it is their house. And so it's also, I kind of started inviting customers to see what I'm doing. So now they're not just seeing that I'm putting this part in, they're seeing that my value, my skill, what I know, the tools that I'm using, how I'm doing stuff, and they have more of appreciation for what I'm doing. So as you work through this, be mindful it's their house and their big investment, and then invite them to be a part of that experience. They're going to have a whole lot more trust in you than they would with just any stranger they're calling off the internet.
You're 100% right. I love doing that. Just being able to educate. I'm like, do you want to know how this works? And sometimes they say no. Sometimes they're like, yeah, tell me. And if you are anxious about them kind of like watching you all the time, sometimes you can like even over educate them to the point where they're like, all right, I trust you. I don't even want to know anymore. It's too complicated. Go do your thing, and So that's great. But it is good to be able to just give them some ideas of what's actually happening. And like you had mentioned, about the humidity and comfort, and you can describe actually what's happening, what the most efficient ways to run your system are and things like that. So while you're still doing your work. So, well, Ty, what do you think about today's questions?
Oh, it's a great day. I love it when people are asking questions and they're curious and they want to know more. They're not understanding why. And it's really an honor to be able to be here,
Yeah.
be a part of that. And I really always enjoy your insight, your input to it. And I think it was absolutely a great day.
Awesome. So if you want to learn more about Ty, make sure to look him up, Ty Brannaman and Love to HVAC. And I hope you enjoyed today's episode, and see you next time at the AC Service Tech Answers podcast.